Right, so let's have a look at calculating half-lives. Now there's an example on the top of page 32, and this is a good way of setting out all of these half-life calculations, if you like. This is like the non-methods maths approach, where you would write down the activity, however it is represented in the question. It could be in becquerels, like the question could be in becquerels, it could be in counts, it could be in decays, like this one is. Okay, whatever that is, it has one section. Then we can count the half-lives. And this will just be in whole numbers, 1, 0, 1, 2, whatever, and then time. In this case it's in days, but it could be hours, seconds, minutes, depending on the question. So these parts here are the same for all of these questions, but the units might vary just depending on the decay of the particular isotope. So we're told that the half-life of iodine 131 is 8 days, and the initial activity of the sample is 120 decays per second. So after 0 half-lives, we have an activity of 120 decays per second, and that is also at 0 time. So the most common error students make is by starting at 1, okay, and then they're out by a half-life. So you have to remember that at time 0, 0 half-lives have elapsed. And then we want to know what's the activity after 24 days. Well, after 1 half-life, 8 days have passed. Yeah? And after 2 half-lives, another 8 days have passed. And this is another place where students can get confused, because we know that the activity is going to halve after each half-life. So this would then be 60, and this would then be 30. Some students get a little bit confused and double the time. We don't double the time, we just add the half-life time on down the bottom here. Okay, so these are halves, but this is doubling. Sorry, not doubling. This is not doubling. This is just adding the correct number of days for the half-life. So we're going to add another 8, and we get to 24. And that's what we were asked, was what's the activity after 24 days? And it would be approximately 15 counts, decays per second after 24 days. Now the other way that you can approach these calculations, and if this resonates for you, then by all means, that the fraction of material left after n half-lives. Okay, this is the number of half-lives. And so how many half-lives after 24 days? We know it's 24 days have elapsed. And we know that the half-life is 8 days. So that would give us then 3 half-lives. So if we substitute into this, we would have 1 divided by 2 to the power of 3, which then gives us the 15 counts. Does that make sense? Okay, because this is an exponential decay. This way or this way. Either way is totally acceptable. Now, if you're using this method, you must make sure that you show you're working. Okay, because if you ended up with the wrong number for some reason, you type it into your calculator wrong, you just write the answer, you'll get nothing. Okay, but if you could make a series of mistakes with this and still get marks, if the person marking it can see where you've made the mistake. For example, if you started with the 1 half-life instead of 0, well then someone could look at your work and see that you understood the process, you just made a mistake. Whereas if you're using this, like I said, you must show the thinking that you have used in order to arrive at your answer. Okay, so if we look at, do we want to look at question 32 perhaps as a, or are you happy to just have a go by yourselves, or?
We just do it.
You just do it? Okay. This is a very clear way of showing your thinking. Okay. This is clear too, but while you're working through it in your own mind, this can be a good way of approaching it. Okay, so we've got all those questions that start now on page 32.